Hello, my dear friends. How are you all? I hope you all are good and fantastic. So, friend, today we will start polynomials. Okay, so you are very welcome in this lecture number one. Okay, so I hope you will enjoy this lecture, and this topic is very amazing. Okay, this chapter is very amazing. You will definitely enjoy these chapters. Okay, so now without wasting the time, let's start it. Yes. So first of all, so in this chapter, okay, so here we are going to discuss the complete explanation of what is polynomial and its type. Okay, so in this chapter we will learn a lot of topics like polynomial, what is polynomials and its types, algebraic expressions, degree of polynomial expressions, graphical representation of the polynomials, equation, factorization, relationship between zeros and coefficient of polynomials, and so on, with so many examples. So friends, are you ready? So now, so first of all, our first topic is that introduction to polynomials. Okay, so before starting the introduction of polynomials, we have to know what is algebraic expression. What is algebraic expression? Okay, so algebraic expression we will learn. Okay, so an algebraic expression is an expression. An algebraic expression is an expression made up of variables and constant along with mathematical operator, like made up of made up of algebraic expression made up of variables. Okay, and what, yes, and constant numbers like 2x. This is a algebraic expression with mathematical operators, means with the sign of plus, minus, multiplication and division, like 2y. This is a algebraic expression. Okay, or 2x square plus 3x. So these all these are the example of algebraic expression. Okay, I hope you get this point. Now an algebraic expression is a sum of terms, which are considered to be building blocks for expressions. Okay, now what is terms? A term is the product of, like simple, we have written as a term is the product of variable and constant. Okay, like 2x. Simple, this is a term. Okay, this is a term, and the combination of such terms are called the algebraic expression. Okay, I hope you get this point. What is term? Simple, term is the product of constant number and variables. Now we have to see a lot of examples. So like 5x, it is also a term. 2.5x, it is also a term. It constant may be negative or positive, or maybe in fractions, maybe in decimals. Okay, yes. So now in this case, in all the terms, in that case, like 2 is the constant term, 2 is the constant, and x is the variables, x is the variable. Okay, I hope you get this point. Okay, and here is 5 is the constant and x is the variable. Okay, so that these are the terms. Okay, now let's talk about the another example like 5xy. Okay, we have the variable x and y and the constant term. Okay, so this is the product of constant and the variable terms. Okay, now let's take another example, 4x square y. It is also the term. Okay, so here here terms is the product of 4 into x into x into y. Okay, so this term is made up by this. Okay, so I hope you get this point. Now the constant in each term is referred to as coefficient. Like 5 is termed as coefficient, is termed as coefficient. 2.5 is termed also as coefficient, and here is also here we can say is variable. Okay, so coefficient is always with the written with the yes variables. Okay, so now here we are seeing that the example of expression are, it is the combination of terms with the help of mathematical operators, like 3x square y plus 4xy plus 5x plus 6. So how many terms in this? Can you tell me? Yeah, so there are 1, 2, 3, and 4. So how many terms? There are 4 terms. Okay, so what is terms? Terms is the combination of constant and the variables. Okay, I hope you get this point. Now an algebraic expression can have any of the numbers, can have any of the terms. Okay, there is no limitations of the terms. Okay, it may be 4, 5, 6, 7, infinity, till infinity. So the basic so the basic standard form of the polynomial is that we have a function of f of x, and so the term is a naught plus a1x plus a2x square plus dot plus an x raised to power n. Now where this is the standard form. Okay, now here a naught, a1, a2, a3 dot an. Okay, these are what? Yeah, these are real numbers. These are real numbers. Okay, and x square, x raised to power n, this goes to, yes, they are variables. Okay, these are variables. So now, and the constant term which is attached with the constant term which is attached with the variables are called coefficient. Okay, as I told you. Now if we talk about a1, we can say that a1 is the coefficient of x. Okay, we can pronounce it as a1 is the coefficient of x. Now what is coefficient of x square? Yes, of course, a2. Okay, so we can say that like this. Okay, now, okay, so an algebraic expression can have any of the terms. Okay, so the coefficient in each term can be real numbers. Coefficient can be real numbers. There can be any of the variables in the algebraic expressions. Okay, but now the most important thing is that the exponent on the variables, like 1 means power of the exponent, power of the variables, like 1, 2, 3, and so on, must be rational number. Okay, I hope you get this point. If it is not the rational number, then it will be not the polynomial, then it will not polynomials. Okay, I hope you get this point. it. Now let's move on. Yes. Now the important part is polynomials. Okay, so an algebraic expression can have exponents that are rational numbers. However, a polynomial is an algebraic expression in which the exponent on the variable is a whole number. Okay, so what is algebraic expression? Algebraic expression are those expressions which have the exponent of that rational number. Okay, but in the polynomial, if the algebraic expression having the exponent in the what? Yes, in the whole form, means in the whole number. Okay, in the whole number, the exponent of any variable is a whole number, then that will be called as polynomials. Let's suppose if we have an example 5x cube plus 3x plus 1. Okay, so this is the polynomial. It is also a algebraic expression and polynomial. In that case, exponent is a whole part. Exponent is a whole part, means it is of a round figure, not a points, not in a decimal number. Okay, okay, I hope you get this point. So we can say that all polynomials are called algebraic expression, but all algebraic expression we cannot say that are polynomials. Okay, now, okay, so now another example is that 2x plus 3 under root x. Okay, 3 under root x. Now, is this a polynomial? Of course not, because the power of x is 1 by 2. And what is polynomial? Polynomial are those algebraic expressions which have the exponent in the whole number. And this is not a whole number. This is not a whole part. This is a fraction part. Okay. So, but we can say it is an algebraic expression while it is not a polynomial. Okay. It is not a polynomial, but it is algebraic expression. We can say it is algebraic expression. Okay, I hope you get this point. So I hope you understand what is polynomial and what is algebraic expression. So all the game is of the part of exponent. If the exponent is in whole number, then it will we can say that it will polynomials. But if the exponent part is not in a whole number, then it is not the polynomial. Okay, now we have to identify which one is the algebraic expression. Oh, sorry, which one is polynomials. Okay, all these part are the algebraic expression, but we have to identify which one is polynomials. So if you talk about the first number 4x square minus 3x plus 7, yes, it is polynomial. Okay, now can we say that minus 1 upon x, oh sorry, 1 upon x into x minus 1 into x minus 2, is this a polynomial or not? So let us solve this. We cannot identify directly by saying by seeing that this is polynomial or not. We have to firstly solve these steps, solve this expression. Okay, so we can write x minus 1. Okay, because this the power of x is 1. If you goes in the if you take in the numerator, then it will become x raised to power minus 1. Okay, this is x minus 1 and this is x minus 2. Okay, now if you solve it, x raised to power minus 1 and it will become x square minus 3x plus 2. Okay, now finally we get x x minus 3, okay, plus 2 raised to power x minus 1. Okay, now here is x raised to power 1 minus 3 into x raised to power 0. X raised to power 0 means 1. So we can write it as a 1. There is no change, plus 2 raised to power minus 1. Now here is this power is not a whole number. So we can say that it is not polynomial. Polynomial. Okay, I hope you get this point. Now again, x square plus x raised to power minus 2, because this is in denominator. Now when it will goes to the numerator, then the power becomes negative, x raised to power minus 2. Okay, now again this is in negative form, so again this is not the polynomial. I hope you get this point. Now now yes, degree of a polynomial. Okay, so now what is degree of a polynomial? Okay, so you have to be listen very carefully. So for a polynomial, okay, for a polynomial in one variable means it has just only one variable, not another variables, like 2x square plus 1. This is the polynomial in one variable. If like this 2xy plus 1, this is the polynomial in two variables. Okay, we are just talking about degree of polynomial in one variables. Okay, so for a polynomial in one variable, the highest exponent on the variable. Okay, so the highest exponent in the on the variable in the polynomial is the degree of polynomial. Means we just have to see the highest number of exponent, highest number of exponent. For example, we have the expression like this: what, x square plus 2x plus 3. This is the polynomial in one variable. And what is the highest power of exponent is 2. So what is the degree of this polynomial? So the degree of this polynomial is what? Yes, 2. So degree of polynomial is 2. Okay, I hope you get this point. Now we are talking degree of polynomial in one variable. Now, so this is degree of polynomial in one variable. Now let's talk about the degree of polynomial in two variable. So first of all, the example of the polynomial of two degree. In case of polynomials in more than one variable, means this is the degree of polynomial in one variable. Now one variable. Now let's talk about degree of polynomial in two variable. Now, in case of polynomial in more than one variable, the sum of the power of the variables in each term is taken up. Okay. And the highest sum so obtained is called the degree of polynomial. For example, yes, we have an expression like this: 5x cubed plus 6x square plus 12y cube. Okay. Now, in this case, this is 2. In this case, the highest degree of polynomial, yeah, this is the power of 3. This is of the power of 2 plus 2 means 4. This is having the power of 3. Now the highest is 4. So the degree is 4, is of the order of 4. Okay. So I hope you get this point. Yes. Now types of polynomials. Okay. What are the types of polynomials? So friends, basically polynomials can be classified on the basis of terms and degree. Can be classified as the based on the number of terms and degree of polynomial. So first, polynomials, types of polynomials based on number of terms. Based on number of terms. Okay. So now in this case, again polynomials are divided into three parts. Like first part is monomial. Monomial. What is monomial? A polynomial with just one terms. A polynomial with just one term. For example, 2x, 6x square, okay, 9xy. So these are the polynomial with just one term. So these are called monomial. Okay. Now second is binomial. Binomial. What is binomial? A polynomial with two terms. Okay. For example, 4x square plus x. Okay. 5x plus 4. Now the third is trinomial. What is third? Third is trinomial. So the polynomial with three terms. With three terms. For example, x square plus 3x plus 5. This is a polynomial with three terms. Okay. Now types of polynomial on the basis of based on degree. Okay. Based on now. So on the basis of degree, the polynomials are divided. Okay. First is linear polynomial. First is linear polynomial. Okay. So now a polynomial whose degree is 1. A polynomial, a polynomial whose degree is 1 is called linear polynomial. For example, 2x plus 1. Okay. So in this case, the maximum degree is 1. So what is the degree of this polynomial? 1. So this is linear polynomial. If we talk about second one is quadratic polynomial. Quadratic polynomial. What is quadratic polynomial? So quadratic polynomial are those polynomial which having the maximum number of degree, which having the degree is 2. Okay, so a polynomial of degree 2 is called quadratic polynomial. For example, 3x square 3x square 8x plus 5. So here, if you see that the maximum order is 2, so the degree is 2. Degree is what? Yes, degree is 2. So this is the quadratic polynomial. Again, now the third part is this cubic polynomial. What is cubic polynomial? So the degree, when the degree of the polynomial is 3, then this will be called cubic polynomial. Okay. So for example is 2x cube plus 6x square plus 10x plus 20. So here the maximum power is 3. So the degree is 3. Okay. So it is of the order of 3. So we can say that this is a cubic polynomial. Okay. So I hope you get this point. Now let's move on. Yes, additive inverse of a polynomial. So now what is additive inverse of a polynomial? Let's see that. Yes, a polynomial, let's suppose we have a polynomial q. Let's suppose, for example, we have a polynomial q is 3x square minus 5x minus 7 plus 7. Okay. So a polynomial q is the additive inverse of polynomial p if the sum of p and q is 0. So what is p? So p is minus 3x square plus 5x minus 7. If we sum p and q, then we get, if we sum p and q, then we get 0. Then we get 0. So the additive inverse of a polynomial is obtained by reversing the sign of each of the coefficient. Okay, reversing the sign of each of the coefficient of the polynomial, like here is 3, here is minus 3. Okay, here is minus 5, here is plus 5, here is plus 7, and here is minus 7. I hope you get this point. Now, value of polynomials. What is the value of polynomial? The value of the polynomial fx at x is equals to some point is obtained by substituting the value of x in the given polynomial. Let's take an example. For example, if we have a polynomial of x is equals to 6x square plus 7x minus 2. If if we put x is equals to 1, then it will become p of 1 is equals to 6 of 1 square plus 7 of 1 minus 2. Then it will become 6 plus 7 minus 2, and the result is what? So the result is 11. This is our answer. Okay. So we can say that the value of p of x at x is equals to 1 is 11. Okay. Now let's move on. Yes, zeros or roots of polynomials. If x is equals to, if we have a value x is equals to of a polynomial at x is equals to a. Okay. This is x. Okay. So this is the root or zero of the polynomial. This is the root or 0 of polynomial p of x. Okay, if p of a should be 0, p of a is equals to 0. So in other words, x is equals to a is a root or 0 of a polynomial if it is a solution to the equation p of x, if it is a 0, if p of x is equals to 0. I hope you get this point. So the process of finding the zeros of p of x is nothing more than solving to the equation p of x is equals to 0. If we want to find these zeros of a polynomial, so we have to directly put p of x is equals to 0. Okay, so I hope you get this point. So now we are finishing here. So I hope you understand this lecture. So thank you very much, guys. We will meet in the next lecture.